Hello, and welcome to the Ocean News Podcast, an audio series that takes you through the breaking news and the biggest stories from the Oceanographic newsroom. I'm Rob Hutchins, news editor here at Oceanographic Magazine, and in this episode, I'll be leading us on a deeper dive into one story from the newsroom today. And today, we're talking about the global impact we might just be making every time we order a fish and chip shop favourite. Now, I love a fish and chips as much as the next person, but a new study released today by the University of Exeter as part of its work with the Convex Seascape Survey could just have us all thinking twice about our usual order and the role that the fish we eat have to play in the wider conversation about climate change. Yes, this study is all about something called bioturbation, the process by which different species of fish here in the UK interact with seabed sediment and how crucial their behaviour is in keeping the delicate marine ecosystem in check. Because it turns out that some of our favoured fish to eat also play a big role in the seabed sediment process, findings that could just help to recalibrate our approach to marine protection and, crucially, the subject of overfishing. To help us wrap our heads around this new study, who better to talk with than the study's author herself, Mara Fisher, a PhD student at the University of Exeter and an emerging specialist in the vastly understudied subject of marine bioturbation. Mara, welcome to the Ocean News Podcast, and thanks so much for taking the time to chat with us. Really fascinating study. I'd love to, actually, let's start from the very top. And would you be able to talk to us about what the study was, what you've actually found?
Sure. So I guess the main aim of the study was to really highlight this largely overlooked role that fish play on the seabed. So we have quite a good understanding how some other groups, such as invertebrates, contribute to bioturbation, which is the mixing of sediments, essentially. And we have some global estimates of bioturbation in the oceans, which are really big numbers, but we don't really know how different phyla sort of contribute to that. So this paper aimed to really highlight that fish are also really important bioturbators that play a really significant role on shaping these seabed ecosystems, and we shouldn't be overlooking that.
Yeah, and you used the word bioturbation a couple of times there. Could you give us sort of a rundown of what actually is bioturbation? Because there's different modes of it as well, isn't there? So if you could explain that for us, that'd be great.
So bioturbation is essentially a term we use for all animal activity that reworks or mixes the sediment. So if you think about this, most people might be able to imagine this more in a land-based context. So if you have something like an earthworm in your garden, that's essentially bioturbation, the earthworm moving through the sediment, mixing sediment particles. So that's what we mean by bioturbation. In the seabed context, that's a really important process because that, for example, introduces oxygen into the sediment, which allows other things to live there. It's really important in moving around and cycling nutrients, including carbon. And so it's a really, really key process.
And it's key in a wider aspect as well in terms of stabilizing the ecosystems and what that means for climate change, locking away carbon, and you zoom out and there's like a crucial role that plays in carbon capture. Would that be right?
Yes. So we know that bioturbation is a really important process for biogeochemical cycles on the seabed, and carbon does come into that. So bioturbation is likely to influence how carbon that reaches the seabed is either broken down, potentially remineralized, or buried in the sediment. So if we're thinking about this in terms of climate change, obviously the oceans take up a vast amount of CO2 every year. So really, really important carbon sink. And a lot of this carbon eventually ends up on the seabed. And bioturbation plays an important role in sort of deciding the fate of that carbon. So whether it gets re-released, which wouldn't be great in terms of climate change if it ends up back in the atmosphere, or whether it gets buried and locked away, potentially helping us slow down climate change.
Yeah, it's so interesting. So we've got all these fish then, all these species of fish that have got playing varying degrees of roles in their bioturbation. the teeth back in bioturbation modes, activities, and you've ranked these through this study. You've been able to rank these. Would you be able to talk us through that sort of ranking system?
Yeah, so we decided for this study to just focus on the UK context. So we looked at all fish that we get here in the UK seas, and then we basically grouped them based on how they interact with the sediment. And we developed these 5 new what we call bioturbation modes. So they're essentially the way that these fish rework the sediment. Something similar has been done for invertebrates before, but these invertebrate modes weren't very suitable for fish. So we essentially adapted them to make them more applicable to fish. And for example, ways that fish interact with the seabed include through activities such as foraging. So a lot of fish feed on organisms that live in the sediment, so things like worms or bivalves. Some fish actually properly dig into the sediment and excavate quite substantial amounts of sediment when they're foraging. Other species create proper burrow systems, so they actually live in the sediment.
Yeah.
Other species build nests to lay their eggs in. So there's all these different activities that fish do that influence the movement of sediment on the seabed.
Yeah, interesting. And what's more interesting as well is that you found that the ones that had the biggest bioturbation score were also the ones that were sort of more vulnerable or being overfished. I think Atlantic cod were second on your list, but European eel was number 1, right?
Yes, Atlantic cod was definitely up there. The top species were, yes, European eel and Atlantic hagfish. But yeah, that's right. So we found that a lot of these really key bioturbators in the UK context are also quite vulnerable to exploitation. I mean, everyone knows cod. I mean, it's a staple in the fish and chip shop. So people might be surprised to learn that they actually play a really, really key role in maintaining seabed ecosystems by potentially changing or losing these species through these human threats, such as commercial fisheries. We might be fundamentally changing seabed processes, which might eventually end up affecting our climate.
Yeah, which is such a key. It seems like such an important finding that it's sort of unfathomable that we haven't stumbled across these or made these links and connections before. So, okay, so looking at that scale that I've seen this morning, you've got Atlantic cod quite high up, and then at the bottom of the scale, you had, was it the red?
Gurnets.
Yeah, right. So what have you made some sort of a hypothesis behind why is it that it's the Atlantic cod that has this high bioturbation score? Why is that then? Is it just an unhappy coincidence for the cod that it's also the most tastiest and the one that we want to fish the most compared to the ones at the lower end that are less commercially fished?
Yeah, so how we essentially assess the bioturbation impact is we took into account the method of how the fish interact with the sediment, so the bioturbation mode, the frequency at which they do that. So whether they're likely to interact with the seabed all the time, maybe just once in a while. For example, nesting species might not do that very often. And then also the size of the fish, because that's going to influence what sort of area of what sort of spatial extent of disturbance they're going to have. So I think a lot of these top bioturbators that we identified tend to be quite big species. Big species tend to be more vulnerable to exploitation or potentially also more targeted. But we do also have other species that are important bioturbators that aren't actually commercially targeted, but they still tend to be vulnerable to potentially other factors. So one important species we identified was the common skate. So this is a really, really big species and that we get here in the UK, and they're really, really rare. So they're classed as critically endangered on the IUCN Red List. And this is because they have been exploited a lot in the past. They're not actually targeted now, but it's just also showing that we've probably already seen quite significant changes historically in these relative abundances of different bioturbators, which might have already changed the seabed ecosystem, which we don't really know about.
Oh, wow. It's so interesting. It just unlocks a whole sort of world of new questions and research that needs to go from here, right?
Yeah.
So, what impact do you hope that your study will have then in terms of how people approach, I don't know, the idea of conservation or the needs or protect UK waters, or specifically these species of fish that are sort of targeted by commercial fishing?
So we hope that our study is sort of a first step to allow us to bring fish into this conservation about seabed management, seabed conservation, to allow us to have sort of a bigger picture. Because as I was saying in the beginning, as until now, fish have been largely overlooked in having this key biotopation role in the seabed. And that means that we haven't been able to include them in any sort of management decisions or when estimating these global estimates of biotopation, for example. So we hope that this sort of simple index that we outline in the paper that allows us to quantify a species biotopation impact will be useful to other researchers to allow them to include fish when they're thinking about maybe protecting an area from seabed disturbing activities, to really have that sort of holistic approach to seabed management.
Yeah. Oh, hopefully, because it seems like such a critical thing. What sparked the sort of the idea for you then to take a look at this area of the seabed?
Well, I'm doing a PhD at the University of Exeter, and my PhD is part of a research project called the Convex Seascape Survey. And this is a 5-year collaborative research project between the University of Exeter and Blue Marine Foundation, funded by Convex Insurance. And this project's really trying to better understand how the seabed, especially on the world's continental shelves, is contributing to carbon storage to help us fight climate change. So the whole sort of idea of my PhD is to look at this in the context of ecology. So what are the links between carbon storage in the seabed and the ecological communities that live there? So I've been thinking about how fish communities and carbon might be sort of interlinked. And then other people on the project are studying similar things, but for in the context of invertebrates. So how do things that live actually in the seabed, how do they contribute to carbon storage? Also thinking about this in terms of biotopation. So that sort of sparked my ideas. So wait a minute, why is no one talking about fish biotopation? Because it seems like they're doing sort of exactly the same thing, potentially even on a bigger scale. So that's, I guess what sparked.
Yeah.
Yeah.
Oh, so interesting. So where do you think your research goes from here? Is this something you're going to keep sort of investigating and looking into?
Yeah, for sure. I'm hoping to basically apply this framework that we developed in this paper to some of the real world data that we've collected now. So it's part of the Convex Seascape Survey, collected a lot of data in the field in different areas in the UK and abroad. And in these areas, we've surveyed ecological communities, including fish, in sort of different levels of protection. So we've surveyed marine protected areas where no sort of extraction of any life, including fish, is allowed, and where the seabed is protected. And then we're comparing that to areas nearby which aren't protected. So there are activities going on there that are potentially both disturbing the seabed and extracting fish. So I want to see how that compares, essentially, if there's differences in species composition, and potentially do we have more important biodiversity species in these protected versus unprotected areas. So yeah, I think the next step is to sort of apply this to some actual field data that we've collected.
Yeah. Amazing. Oh, well, best of luck with the continued research then in that area. And congratulations on bringing this to light. It's such a deeply interesting aspect of the seabed and biodiversity across it. And it feels like it's going to be crucial, this sort of knowledge going forwards, in terms of how we conserve it and how we best approach sort of like the bigger picture of climate change and the role that all of these fragile ecosystems have to play towards that larger issue. Would there be one message that you'd want someone to come away from this from, whether it's someone thinking about the overfishing aspect or the conservation aspect? What would be the message?
I guess the main message would be that we need to sort of expand our view of how we think about fish and their role. So obviously they're really important food source for us, and that's not going to change. But I think we just need to start thinking about fish slightly differently and appreciate that they have a lot of different critical roles, which are not just important for really small localized ecosystems, but important for the whole global climate.
Yeah, I love that. Yeah, that's a great message. Well, yeah, thank you so much for your time. I really appreciate it.
Awesome.
Thanks so much again. So that was Mara Fisher, a PhD student at the University of Exeter, on her fascinating study into bioturbation on the seafloor here in the UK, and the fish most responsible for keeping those ecosystems in check. To learn more about this story or other stories on life on the seafloor here in the UK or across the globe, head to the Oceanographic Newsroom. This has been the Ocean News Podcast. I've been Rob Hutchins. Thank you for listening.